Hey, welcome guys. So let's solve this 257 binary tree path. This problem is really this code is really important to solve other problem like 908A in the other problem. So basically, this problem basically will give you the code. Now you can start from roots and go to all the paths. Sorry, all leaves. So given a root of binary tree, return all root to leaf. Right? This is important in any order. So 1 to 5. So you 1 to 5, 1 and 3. Okay. So simple problem. If there's no roots, right, you just return none. Otherwise, you initial answer. Okay, so now you start from the empty. You start from empty string, right? And then you go start from you that value at the current node. So for example, you start from here. You start from. Let me just run the code. 1, 2, 3, 5. Let me just go through the code. Okay, so now when you start from roots, right, you get this. Okay, and if not no left and no right, so this is the condition that you reach a leaf. If you reach the leaf, then you just return this. So this dot will make the results into a string. Okay. And so, but if there's still no left, there's still left child, then you go through left, but you add this arrow, right? So in this case, there's still 2, right? So I added this. So now I become 1 and this. And so I added the value, so become this. Okay, and this will keep going, right? Because there's still no right. And I add another one. And the final, I arrive here. And then for once I arrive this 5, there's no rest, right? So I can just append. So basically, a simple idea that if I see if there's no left and no right, then I just get the answer. If there's no left, then I go left. If there's right, I go right. That's it. And then you just return the path, and you just go around this path. So this is somehow like a DFS, and then you return it. Okay, so this is a very important technique for you to solve other problems, because there are many problems asked about the property of all root to leaf. Okay, so that's it. Just very straightforward. Okay, so see you guys next videos.